fairly typical of a north-south-ish joint-aligned passage. It forms a narrow slot, very high, and it clearly postdates the very large chambers and passages that we saw up in the Nome and Chasm passageway. It probably formed by very rapid down-cutting in response to the main stream down-cutting. So this is a consequent stream to that. Gradient in sections is commonly controlled by the dip and the verticality by the direction of the main joint. We're at the junction of Salubrious Passage and passages leading to the Trident and the Judge. In the event of two water streams coming in, there's the potential for increased dissolution as a result of mixed corrosion. Waters adjusted to different levels of carbon dioxide meet, and when they mix, they can only be more aggressive. The degree of aggression need not be high, but it's you've got time, immense amount of time, in order to produce a passage. Quite often, where two passages of similar size meet, then at the junction chamber is usually very much bigger than the sum of the two passages. Okay, we're in here looking at a passage which leads from Salubrious Passage towards the Trident. It is characterized by a simple arched roof. This is a primary solution tube which extends through a large part of the cave. The tube maintains its dimensions and is found at Smith's Armory in Ogof Ffynnon Ddu and extends all the way to the west and south, at least as far as Marble Showers. It is a very important drainage element in the phreatic history of the cave. The scalloping on the roof and on the upper part of the walls indicates a fairly slow water flow. At the lower levels, the scalloping is very much closer together, indicating a more rapid flow. And that's the sequence of the bedding as we come down. We are here about 5 to 8 meters above the base of the Dolomite limestone, and that's about the lowest exposure we can find in the cave. It's changed a little bit in character. It has much more dolomite, which is a magnesium calcium carbonate in it. The dolomite is rather more resistant to erosion than calcite, and therefore it projects into the passage as fins. In particular, it's the top of some of these beds that is dolomite, or in other cases, the whole of the bed is converted to dolomite. In this area, it looks as if the dolomitization occurred before the induration of the calcite limestone, so there was a conversion in situ shortly after the calcite beds were deposited. Limestones may be partly bioclastic, with these broken shells in, cemented frequently by calcite, which has been recrystallized so that the original nature of it is obscured. The cement area often contains some organic matter as well. That gives the colour to the rock, and it's probably where most of the radioactive elements are within the bituminous parts of the calcite cement. One of the reasons why radon is such a problem in some of the caves, it's because the uranium, the parent of radon, is uniformly distributed and has a very large specific surface area. For its mass, it covers a large area. This is a depth assemblage of a fossil called compositor. It's a broken shell bank which shows that the energy here was quite high, fairly shallow water. This assemblage is possibly indicative of very rapid accumulation, so we may be looking at something which accumulated over a few years or even part of it. Marble showers, for example, is a prime example of a shattering of limestone, probably in that case related to faulting in the area. So you get a very broad fault zone with a great deal of smashing up of the rocks on either side, dilational effects which then fill up with calcite.